Ok, boa tarde a todos. Então vamos começar. Alguém daí de casa pode dizer qualquer coisa para ver se... Ok, já ouvi qualquer coisa. Eu acho que foi a Sara, não foi você que falou. Você esqueceu do comando? Pois só, eu sei, só agora é que me lembrei dessa ideia, mas era porreiro. Ok, então, in English, right? This class is in English. So, good afternoon to all. Happy New Year. As you've seen this morning, today we are working on calibration. And let me start here the GitHub. So let's go to the part 12. And I'm not sure what I should do. I can continue. I can pick up where I left by the end of the theoretical class, but I'm not sure that's the best thing to do. So what do you suggest? First of all, do you have any questions concerning these initial exercises? Any question? You posted something, didn't you, Jose? Is it solved or not? Okay.
But I don't know why. No, I know how I solved it, but I don't know why.
It worked? Okay, that's a good place to start. So if you can share it and explain the problem to us, then we continue. So I remember, now I'm starting to remember, the problem was about having the topic name pushed to the player space, right?
More or less. The problem was that odometry was not on the namespace, was not pushed on the namespace. And by consequence, the laser scan was not appearing on FBs.
Okay. That odometry part should be, I think, automatically pushed to the namespace because it's produced in the chakra.
Yes, I'm going to explain you how I done it. But
okay, let's see it.
Okay, so basically, I just put the group
namespace, yeah, right?
Namespace, and then I use this node, robot state publisher. But previously, I had something like this. So node. And this parameter inside. So
that makes it a local parameter, no?
Yes, because I thought that the F prefix was a parameter inside ROS node, robot state publisher.
So this param keyword can be used outside the node or inside. If it is used inside, it's a local parameter. That means it's a parameter from the node. In this case, the robot state publisher node.
Yes.
The robot state publisher node, I don't think cares about a parameter like this. So it doesn't use this parameter.
That's why the other...
It wasn't working.
Yeah.
Who is going to use this parameter is the gazebo. That's why this parameter needs to be outside.
Okay, and then I thought about it and I put it outside because I tried everything and outside it worked.
Okay, great. That's a good idea. That's good. Where are you loading your robot? It's below there. The robot description is below. You should use the tabs in order to better identify who's inside your group namespace.
Everything.
Okay, so you don't have to do that. You can select everything and then tab.
Okay.
Or even better, Control A,
All.
Control I. I for indent. No, doesn't work?
No. My shortcuts are all messed up.
Yeah,
but
also the others are there, yeah. So if you do this, you will realize that so let's go one by one. The arguments, so arg, model, xpos, ypos, zpos, they don't need to be inside the namespace. Okay. Those I take away. Then the TF prefix actually does have to be inside the group namespace, okay? Robot state publisher the same. Robot
Yes.
description. Also because the parameter is not called robot description, it's called PSJPedro robot description.
And also this node.
This
Or this-
one I didn't put inside.
No?
But I think I put inside. Okay, I will show you my code. Let me show you my code.
Yes.
It's the same. I think your solution is better even. I will show you mine. I think I like yours better. Because okay, so let me shut down everything, otherwise I don't know where I am. Okay, and now we go to bring up and the spawn. Let's put side by side. And so you see that I put the spawn, where is it, the spawn? Here, outside of the group namespace, but then I had to put the group namespace here. So I, mine too. Mine too. This is my bring up. The question, so mine also calls what your calls. The question is whether or not to put the spawn inside the group namespace. So inside this group, you put the selected part inside the group namespace. Well, but if you do good, you should say it's on purpose because it's better than my solution. Because, look, you put only one group namespace. I have to put several. I have to put one there and one in the other file. So I think I prefer your solution. Actually, I will test it right now to see if it works. So the solution would be to put the spawn also inside the group namespace. Let's try it. So gazebo. Yeah, TP is what I'm using. All right, gazebo. And here I'm going to call bring up. So TP bring up. That's it. Okay. So again, gazebo. I have a different world because I was already doing exercise 9. And here I have my robot. And we were talking about coordinate frames, right? So let's take a look at the TF3. TF3. Okay, so now it's working also just the same. So ODOM and footprint are also pushed to the play namespace. So I prefer your solution. I will adopt it if you don't mind. I'm going to steal this one. Okay, thanks, Jose. Let's continue. Who else needs some help or has some questions? Nobody? By the way, I know many of you are very silent, feeling very bad because you didn't advance and you are still 1 or 2 classes behind. I will do a class, OT class, Orientação Tutorial, for an additional class, just by Zoom, some night, I don't know, Friday night or Sunday night. I will send an email by e-learning. We meet there and then you start asking whatever you need from previous classes. You can also ask here, but I will open an extra class so that you can try to recover, okay? What else? Nothing else? Sarah, you didn't bring the command, right? Ah, that was nice to see. I wanted to try with the command. So you were not successful? Ah, nice. You can show it now. You can show it now. Can you run it? Yes, yes. Okay, you are supposed to show it at the end of the class, so you have a lot of time. For here, I'm not sure. How about you, Gabriel? How's it going for you? Where are you? Mm-hmm. And you don't say anything? Oh, but you can, yeah, but you can say, no problem. Sure. Don't be shy. Mhm. So I cannot see everything because you have the. Okay. So this is your gazebo.chakra. This is your gazebo.launch. So find PG Michelli. This PG Michelli bring up exists. Can you rough it into it? And can bring up and can okay launch empty world dot launch. No, but I don't think that's here. So you didn't have to change this to the P Michelli because this script empty world dot launch you use the one from the turtlebot. You didn't have to because so for example turtlebot 3 has a lot of files and your package also has a lot of files. The question is, when should you use a file from turtlebot 3 and when, option B, should you copy a file from there into your package and use that file in your package? The criteria that I use to do the second and not the first is only when you need to change something in the file. So in this case, empty world.launch is a file. If you were supposed to change something inside that file, then it would make sense for you to copy that file into your own package. If you are just going to use the file and not change anything inside, so you don't need to copy it, okay? So what I suggest, so actually you didn't copy this file, this empty world.launch, where is it? There isn't, okay, so you cannot tell him to find an empty world.launch on Pimicelli, it doesn't exist. It exists on turtlebot3_gazebo, so you have to change that to turtlebot3. You know what I mean? Yes. I mean here. No, I don't. Okay, but I'm saying here, Gabriel, this part here, you have to change it. Turtlebot3 underscore gazebo, like on the line, yeah, I think that's it. Okay, now can you run can you do a ROS launch? Try it. Too many files, right? One gets lost in the midst of. That's it, yeah? So now you have to adjust, exactly. Yeah, the P, you are doing caps lock. All right, so gazebo.launch is neither a launch file in package Gmicheli, nor is package launch file name. Can you do ROS cd p Gmicheli tab? Doesn't work, tab? So that means your file, your package, your ROS package is not being found. Is it like that you write? Is it Gmiche? Does it have Gmicheli? Okay, so you should be able to ROS cd. Okay, can you show me your bash RC? Your .bash RC, that's the name. I wonder if your terminal is properly configured. Well, you don't remember what don't you remember? You can open it in many ways. One of them is like you're doing here, but it's not ./bashrc. It's just .bashrc. There is an extra slash. No, take it away. Take it away. Yes, like this. That's the file name. Okay, so we go down there, And on line 118, you have the source for the rows, and on line 119, you have something to the configuration of the Catkin workspace. Can you go down a bit more still? It's because my Zoom is covering the. Now you have. Oh, that should work. That's strange. One thing, where is your package located? So can you CD your way into the package you've created? Where is it? Yeah? Perhaps, yeah, perhaps that's it. Okay, so this is inside Captain Workspace. Okay, so launch a new terminal, please. Now raw CD yourself into the package. You don't have to know it by heart. It's P G Michelli, P_G, and then tab your way out of it. Tab. Nothing. That's nice. Really? Can you, okay, so write all the way without the tab. So P Michelli _ bring up, right? Bring up. Yeah. Enter. Does it work? Oh. Can I take control of your screen? Let me try to see. I don't know. Actually, I'm asking for control and I don't know what to do. Okay, so I'm still. Well, I don't think so. To compile, but we can try. Yeah. Make. Okay. Okay, we can compile. Multiple packages found with the same name. You have several packages with the same name. You have ROS P12 PG Michelli, bring up, and ROS P12 PG Michelli description. They have the same name.
I think there are two packages named PSR Aladesh inside two folders.
Let's see. Where is it, ROS? No, ROS? Yeah? I can find it, don't worry. CDP12, is it? Then CD, oh, is it you that is always turning on the Explorer? No? Yeah, I'm here in the terminal. Look, I'm here. Now I go into PG Michelli, bring up, and now I need you to put the terminal not in the bottom. Okay, I can do it. Okay, now the bottom terminal is just so I can see what's happening. And now let's see, for example, the package.xml. So this is called description. Yeah, the name is PSR Aladoz. The name of this package is called PSR Aladoz. It should be called P Michelli _ bring up. I'm not sure why it's called PSR Aladoz. Okay, let me see your PyCharm. So, for example, here for the P Michelli bring up, the package should be called. But this is automatically from the moment you create a package. This usually we don't have to touch this. It is strange that It's everywhere, no? But I'm wondering if it's better to do something else instead of refactoring, because when this happens, it's really, I mean, I can refactor, but I'm not sure if in the description it's the same. I think it's going to be the same in description. Look, the description, just a moment. Enter 15, yes. The description here, it's the same. So if I refactor, I don't know which from PSR all of those is supposed to be the bring up and the other the description. Okay, so I can, yeah, okay, we can, okay. So you guys are really into the refactoring stuff. So I'm going to do the refactoring or try. So undo here, undo is like this. Okay, so Control Shift F, Control Shift R. So PSR all those, I'm going there after, and this is going to be P, Micheli. And now, directory. That's it, no? No, bring up, let's go bring up. I think that's it. Let me try. 8 occurrences. I don't know what you did, Gabriel. I have no idea. Okay, now let's try to do the same in the description. Was it? We can actually. Okay, so but we can actually do this. So this is what you did. Cat can make blah blah blah. No, not cat can make. Cat can create. Okay, so you see here. So you did a PSR all of those here. Perhaps you do them both and then you change the folder name. That's not the way to go. You have to change. This here is the package name, and this is not only used to create the folder name. It's used for many other things, as you've seen. Okay, so but we found the problem, and now we are trying to solve it. So we are missing this. Control Shift R. Now PSR all those in the directory description. We are going to change it to, okay, replace all. 8 occurrences again. All right, so now we go back to the terminal. And I forget how, yeah, we are trying to raw CD, yeah. Let's just try raw CD. Okay. No, again, no. Cat can make is used to compile C code, which we don't use, to compile messages or services, which in this case we don't have, and that's it. What I need to do is to somehow tell ROS to search again for packages, for the list of packages. This is done in one of two ways. First, by creating a new terminal. So in a new terminal, I think I know where the P, Jimmy Shelley bring up is. Okay, so I can rock it in now. Because it ran again, so the new terminal, you remember the .bashrc, the new terminal again reconfigured the Catkin workspace because of that source Catkin devel. And now, in this case, the second alternative, if I don't want to launch a new terminal, is to do a source of my .bashrc. So I can do source.bashrc. Wait, cd, now the source. Okay, so this is like starting a new terminal, and now I can raw cd my way into, yeah. Something else. There is a third alternative, which would be raw spark profile. This also updates the package names. There is something here which I don't think still is going well, which is Ross CD, P, G Michelli. If I do this, no, okay, so I have a description there too. Okay, so I think now it's working, Gabriel. So you know what you did wrong, right? It was the creation of the packages. Okay. That's it, no? Do you need more help? Okay. Yes, now we have to go back and try to run it. So now we can. So look, you don't have to go to TSR. So you can go to the GitHub web page for PSR to know what you need to launch. But in this case, it's obvious because you want to launch this file. So this file is called gazebo.launch, and it is on package pgmichelli _ bring up. Therefore, what I need to do is this. RAWs launch. So package name here, Gmichelli bring up, and then gazebo. Okay, enter. Okay, so now we have here a problem, which is the first thing is that you should never have used the package names with capital characters, and that's what he's complaining about. But I don't think this is a problem now. It's just a warning. And now it says, while processing home Gabriel, no such file or directory. Okay, I think when I told you to change this, no, you did change, but you put here Turtlebot Gazebo. I think it's something else. Let me see. I'm going to look in my code. This is the gazebo. Gazebo rows, yeah, that's it. So here it was supposed to be gazebo rows. Right. Okay, new attempt. Again, we go here. Yeah, now we have gazebo running. Okay, so, but if you need anything else, let me know, okay? No problem. Your gazebo is taking a while to start. First time, is it the first time you start gazebo? Okay, so at the first time, sometimes it starts downloading stuff from the internet. And so the first time takes longer. Okay. Let me, who else needs help? No one? Yeah. Mm-hmm. Yes. I don't think I solved it, no. If you want me to create one or to find one that is suitable, send me issue, put an issue up, and then I will do it, okay? No problem. There is someone here in the... Boa tarde. Boa tarde, Emmanuel. How about you, Emmanuel? Do you need some help?
Thank you. Right now, I have no questions because I am a little bit in the back, so I have to push myself.
All right, all right. Okay, so if no one...
I have a question, sorry.
Yeah, go ahead, Manuel.
I'll share my screen. I think it's better. Do you know if there is a way, because if there is a way to do something like this?
That's called recursive argument substitution. And I spent one afternoon or something last year looking for it, and so I'm going to tell you the solution I found, but I have to, well, I will share.
Okay.
So what, by the way, so that you don't feel lost, what Manel is asking for is to do something which is, for example, here, is going to do find pari FNER. So this is like something that must be resolved in the sense that this must be executed and the dollar parentheses find pari FNR parentheses is going to be replaced by the result of that command, right? The problem is that suppose that inside party FNEF I want to run a new command. So first I want to run one, then it gives me an output, and then I want to run another command with the output of the first. And to handle this, I think it's the so-called recursive argument substitution. And I did it where? Recursive, no. It's in the solutions. Perhaps here. Launch, bring up. I think, yeah, nested substitution. This is what it's called. So here I'm doing find Chacro, then find PM Oliveira. I remember this, but I'm not sure if this is a nested substitution. Yeah, it's a nested substitution because the find Chacro is a command that then should have another argument after, which is achieved by running a second command. So you can go to this website. That's what I found. Okay, I think from here you can work your way.
Yeah.
Okay, I'm going to paste this in the chat.
Okay, thank you.
And I'm going to copy paste also this if you, in case you want.
Okay, thanks.
No problem. Chat. Okay, more questions. But it was not necessary, Manuel, to do it. I'm not sure why you are requiring this, but you are complicating your launch file, probably, no?
Probably, but it was because in case we had several players, we just need to change one parameter and everything would change.
That's it. Okay, makes sense. So if you don't have any other questions, I can tell you how we go from exercise 6, that's where we were, I think it was 6, at the end of the theoretical class, which was, 6 here, the visualization part. So we already have the visualization going. And now what we want is to do the teleop. This is the part that Sarah asked in the issues, how it could be done. So let me try to explain. When we have the simulation of a robot, I'm going to launch it here. So first I need to take everything away. Now this is like doing a reset because I don't know. So this goes here. Now, okay, here, bring up part, launch. Okay, so from my bring up, I have this. We've seen it before when I talked with Jose. This is my bring up.launch. So the way to launch my robot is to do the following. First, I launch gazebo. So RAWS launch, the name of my robot, bring up, gazebo.launch. That's just launching the gazebo world. And now it's launching the gazebo world already with the race scenario that is only to be used in exercise 9. And this was done by changing here the gazebo.launch. And instead of saying this, that I wanted to use the Turtlebot treehouse, I said I want to use the fnr.world. So nothing special, just changing the scenario in my gazebo.launch file. Hmm? Strange. Can you show? I think you solved it, but perhaps not in the best way possible. That's why I want to see it. Yeah. Oops. Oh, really? Ah. You did? So why does it work for me? Um, that's strange. Let me see. That sounds like a bug. This is the kind of stuff you should put in the issues, so I can solve. Okay, issues also work this morning. Party FNR, CMake lists, PSNR, FNR. Yeah, right. Yeah. Yeah, I think you're right. Why it works for me, I'm really not sure. I think I have another package. Yeah, could be. Roche CD, Paris, FNE. Yeah, I have one, but I don't think it's where I'm. Paris trabalho 3, Paris FNE. Okay, I will share my screen with you. So I was here checking that I do have Paris FNE. So if I do Roche CD, Paris FNE, I have it. And now, in another terminal, if I raw CD myself into PSF FNER, I also so I have two packages, one with Paris, another with PSF. So for me, it is not a problem. Okay, so I should change this here. Yeah, just the folder name. I know why, because these slides were made for another course which was called Paris. And in September, I changed with a gigantic refactor everything from Paris to PSF. But the folder names do not change, especially if the folder names are only called, are not just PSR or just Paris. Okay, anyway, PSF FNEF. Okay. So, and here I have to put PSF FNEF. And in the README, Paris FNEF. Não há Paris em lado nenhum. Okay. Let's see, I think it still works like this. Okay, next new attempt. Now using the PSR FNEF, and it still works. Okay, so I had two packages, that's why in my case it wasn't a problem. Now, as I was saying, we are going to work on the teleop. The teleop is the component with which we can drive the robot around. So teleop stands for teleoperation. So remote control. We can immediately control this using this .launch file, but I'm going to give you a trick so that you can try to win me in this final challenge of the race. By the way, what we want to do is to race the robot by manually driving it. Did you see this video or not? Okay, let me. So the idea is that we drive the robot around by commanding the teleop and try to do to move the robot around and do the race as fast as we can. And in order to do that, if we can use the standard teleop code, which is this one. I'm going to show you this TurtleBot 3 teleop. So if I go here, TurtleBot 3 GitHub, we can go into the teleop, and then we have some nodes here. Actually, before the nodes, you can see that the launch file here, the one that we are supposed to launch, actually does only one thing, which is to launch this node, okay? So I can actually launch this node here in order to control my robot, not using the launch file, but directly. Or even better, because I know I will want to change something in this node, because I want to make my robot faster. I'm going to copy this code and then use it in my own package. So how do I do that? I'm going into the code, nodes, teleop key. So this is the code that I'm going to copy. Copy. And I'm going to put here, for example, in the bring up, in the source folder, I'm going to create a new file called my teleop P2 P2.5. Sorry? Sorry. Teleop. Wait. Okay, this should be Python 3, and I'm going to take this away. Okay, now, this is the code that they run when we launch this launch file that I was telling you to launch. So I'm just going to run this without the launch file directly in the code. Here is my robot after the bring up. So we have the robot there, the yellow robot, okay? Now I'm going to pick up a terminal and launch ROS run p Oliveira bring up tp. My teleop.py is not what I wanted. I wanted something else. ROS cd p Oliveira bring up tp cd source, and the problem is that it was not executable. Okay, so now I go back and I do the ROS run here Oliveira bring up. Now I have the TP. Now I have the my teleop P2.py. So this is the code I want to run. Now, if we take a look at the code, I'm still not running it. You will see that it is using, so this is a big code. We are going to start in the main. Where is the main? The main is here. So you can see that it will create a publisher of the command val. So we need to change this topic. We need to do a remapping. You know how to remap from the terminal? Do you remember? We are going to do this. CMD val is remapped into Oliveira / CMD val. Okay, because that's the command velocity topic that I'm using. Okay, and now yes, I can move my robot around if all goes well. It's not moving well because I was doing some experiment in the previous class. Okay. What I did was I gave it 90 kilograms of weight or something. It's very, very heavy. That's why it doesn't move. So I have to do a diet here. So my chakra is here. And here, the mass was supposed to be 1 kilogram, and I put it 100. Okay, so again, start a new robot, which is thinner. Okay, and now I'm going to try to drive it again. Okay, do you see? I'm driving the robot. So I'm pushing the keyboard and driving the robot around. So that you know what's happened. So what is happening here in terms of architecture? In terms of architecture, well, actually, if you read Sarah's issues, you know, this is the TF3, doesn't matter now. What matters is how the nodes interact. So this is introspection, node graph. So the gazebo is receiving let me zoom in. The gazebo is receiving command velocities or is receiving commands in the topic PM Oliveira / CMDVal, which are being published by the Turtlebot 3.0, which in that case, that's my node. I should have changed its name. My teleop P2. Okay, so if I run it again, you will see, all right, come on. You will see that, oh, didn't change here. Ah, yes, I need to launch this guy again, of course. Okay, my teleop P2. So now what I can do is to change the code as I see fit in order to drive better, okay, or to have a better performance during the race. So one problem that you can see immediately is this. This is very slow. This is a Turtlebot, so it moves very, very slow. Actually, the maximum velocity is linear velocity is 0.22 meters per second. So we should be able to drive this faster. How can we say, and look, the limitation can be in several places, the limitation of maximum speed. It can be in the real robot or in the simulation of the real robot. So Gazebo can say this robot doesn't go farther than blah, blah, blah. But it can also be, as it was here, in the maximum velocity that you command. So the maximum commanded velocity was also being limited. And this is the limit I'm going to take away. If you go here, you can see max linear velocity, 0.22. So we can actually put here something which is very, very big, like something like this. I'm not sure if it's using the burger or the waffle, so I put 0.5 point something in both. Now, if I run it again, so I have to take it down and run it again. Now I'm going to send, well, should be, yeah. So you can see now I'm moving much faster, okay? But I have to press a lot of times in the move forward in order for him to, for me to get to 1.01. I already pressed 100 times. That's the step. I changed the increment. So let's change the increment like this. And also, for example, that one, the angular. But it was not, sorry. Now I need to delete my robot. Now I cannot find the robot because it should be very, very far away. You see, it's going, still going, but I can find it here in the tree and delete it. And now I can respawn my robot by running the bring up again. Okay, here it is. And now I can drive again, now with better control. Well, not control, with more speed. Better control, not really. As you can see, I'm trying to drive and I cannot. So actually, did you see the video from Jorge Fernandes? It was amazing. I don't know how he did it. He was really driving amazing. Yeah, but he was in the previous class and he said he did not speak. He really did it. I don't know how. Well, but he looked honest. I will show you. So when you do this, when you get to the end of the class, you try to do this as fast as possible. This is nice because it's not just putting infinite there and move very fast because you will not be able to drive the robot around. And you can use several strategies in order to improve. For example, one strategy I use is this. It's really not nice to drive it like this. One thing that we can do is, for example, to have an image. So what if we could have an image of the robot, of the camera of the robot, and instead of looking from here, from this perspective, we look from that image. That would be better, no? So if I do here my RQT and image view, okay. Why is this like this? strange. Let me start a new robot. Yeah. Yeah, the image was all gray because I was already very far away in a region of the scene where there was nothing, just gray. Okay, so now I will try to drive again. Why are you laughing, Lucas? Yes. So, look, I'm going to start driving. I'm doing well. Now I'm doing much better. What handbrake? Come on. You are trying to take my focus away. I'm going even faster now. Por acaso, okay, so here I was, well, in any case, I'm driving much better than before. So looking at the image is really nice, okay, really important. Something else that is would be helpful, for example, is, you see, now I just pressed the space and it stops. When I press space, this code for the teleop immediately sends the velocity 0 and angular velocity 0. So the commands say stop everything. But this is not very useful because, for example, suppose that I'm doing this. Right, and my robot doesn't move, I don't know why. Doesn't move. Suppose that I'm doing the turn completely. By the end of the turn, what I want to do is to have a key which would allow me to do 0 angular velocity, but still be able to continue the linear velocity. So instead of zeroing both, I would prefer to zero only the angular velocity. And this is another key that you can put in that code, okay? So there is a lot of stuff you can do to go faster. This is just about experimenting and learning new stuff, okay? What else? The teleop is done. This part about reorganizing the file, I will leave for you to study. Well, okay, so I will not leave. What do you need today? Okay, so let me do it. Well, first a preamble. Last year, we had more time, and one thing that I told the other students to do that I'm not telling you to do is to try a different gazebo controller, which in the end was not very good. So it was a different way of controlling the robot, or a different piece of code to simulate the robot, which was not very good, and it was much slower. So this year we are not going to do it, and I'm not sure if this reorganization was not just to integrate that part, but I will do it in front of you now. So the idea is that we already have a player URDF chakra and a player gazebo chakra, macro chakra. Actually, we only have a player gazebo chakra, right? So we are going to create a file called properties.chakra, which will contain not only new colors provided by us, but also include the common properties that exist in the turtle bot. So this is the first. I'm going to create a third file, a third chakra, which is going to be here. Properties.chakra. Properties.chakra. Okay. Now look, my pmoliveira.chakra, this is like we did before with the launch file. We created 2 or 3 launch files from a single one, from the turtlebot_how.launch. Here we are doing the same with the chakra files. We are starting to split them into several. So for example, here I'm going to split the pmoliveira_urdf.chakra into one which is still pmoliveira_urdf.chakra, and another with the properties. So here I must include the properties chakra file. I was already including the properties, you see it here? Now I'm just going to include my properties file, which then will include the common properties for the Turtlebot. So here I'm just going to include my Oliveira description TP URDF properties.chakra. Okay, and then the URDF, the properties.chakra will include the common properties from yes. I'm just trying to fight with Zoom. I cannot. There is something there blocking the. And then define additional materials. For example, the orange material. Now that I have, so first I'm going to try to launch this again just to see if it works. I have to take away the robot, which I don't know. I don't think we have a robot now. Or, yes, we don't have. So again, bring up. And I think it worked. So it worked, that's a good sign. Now let's try to change the color of the robot. So to change the color of the robot, I can use, for example, the definition of color orange that I just create. Or, well, let's create a new color. We are going to do a pink color in honor of Sarah. So what is the RGB code for pink? Do you know? Come on. I also don't know. Sarah's color. So this is Sarah's color, okay? Do you want to say some numbers, Sarah? Like this? Okay. Okay, so let's try to use Sarah's color here. You can see here that in some point I have material, light black, dark, 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 and there is a place where I was using the yellow already. Where was it? Yellow? Ah, it was in the gazebo, I think. Yeah, the base link was of material yellow. Now I'm going to do this for material Sarah's color. Okay. So this is what chakras are good for, to define variables. In this material is a variable that I'm going to use later on. Let's see if it works. Oops. Okay. Strange material, this one. I don't know. I'm not sure if this is the color or if it could not find the material. Sarah's color. Sarah's color. Strange. I'm not sure if it worked actually, because it should be okay. Yeah, yeah. I don't think it's working. Yeah, it's not working. I think it's because of the gazebo here. Could it be that it is like this?
Oh, because gazebo has specific name colors.
Yeah, it already has several materials predefined. Probably it already had the yellow. Let's try it like this. No, still no. I wonder why. Material. I think there is a pink in gazebo. Let's try to use it. But a default pink, not one created by us. In this case, the spawn failed. We have to spawn again. No. Okay, so there is no pink. Let's try the yellow. We already did. Yellow works, no? Should work. Yeah, yellow works. Okay, so these probably are the materials in gazebo. Let's see here. Roche gazebo materials. List. Okay. Dark yellow, turquoise, red glow, blah, blah, blah. There is no pink, yeah. Bricks. Okay, let's try the bricks.
Can I ask a question on the meantime?
Sure.
What's the difference between changing the material in the URDF, or the gazebo file?
Again, please, Manuel.
When we do the URDF, we can change the material. What's the difference between changing on the URDF on the gazebo file?
The colors that you use in simulation are not the same that you use when you define the colors in your chakra file. So the colors in your chakra file, the non-gazebo. So okay, so now we have here the initial file, which I'm going to call the URDF.chakra. This also has some colors. I think that is also material, for example.
Line 22.
22, go. No, 22, go. Here, an example. So these materials here are the ones that I can use and define here. For example, if here I define, well, I can use Cyrus color again. Yeah. So, but let's use Cyrus color was with a special, yeah, something like this. So if here, this is what the base link, Cyrus color. Now I think I can, tell me, Manuel.
No, because the geometry is really small, I don't think.
For the base link?
There's a scale over there on line 20. That is 0.001.
Yeah, but that's okay. That's because you can do something on a CAD, on SolidWorks, and then you have to scale down.
Okay.
I think it was using millimeters, and Rod uses meters, that's why you have this scale, I think. I'm not sure.
Okay, sure.
Let's try. I'm not sure it will work. So if we run this, yes, if we go here, it's still pink because the definition of the color there is defined here. Base link is supposed to be bricks, okay?
Yes.
But on RVs, it is supposed to be correct. Let's see. What's the error here? No transform from...
I think you are using, yeah, or no. Okay, sorry.
Yeah, it's a frame ID problem. I'm not sure why. And what's the problem of that? Should be okay, I think. No? It's okay. Page footprint, no? Should be okay. Am I running the robot state publisher? Let's see the TF3. So let's not forget Manuel's question, but we are doing a derivation here. So we have everything. Strange. I don't know why this doesn't work. I think I know. But there is a TF prefix here. Here, M. Oliveira. Nope, not working.
Try the robot's description without the prefix.
I can try.
That's how it is on mine. I don't know.
No, but it shouldn't be, Manuel, because that's the name of the parameter.
Okay.
And if you go here, my parameter is on
Okay,
APM
okay.
Oliveira.
Okay.
So I'm not sure about that one. I mean, about that one, I'm more or less sure, but still it's not working. So why it's not working, I'm not really sure. Should work. No transform from PM Oliveira base link to PM Oliveira base footprint. No transform from PM Oliveira não sei o quê, mas está aqui tudo. Okay. Let me try to restart everything just to make sure. Okay. Shutting down the gazebo. Okay, everything is down. So gazebo first. Now, bring up. Yeah, road throttle now is working. I don't know what happened. Okay, so just shutting down everything. So now we are using Sarah's color. Can you see? Actually, Sarah's color was
Yes.
some special blue. Well, we came up with something here. No, we just invented names, numbers. So your question was very relevant, which is how come we have two different ways of setting color? The materials that we put on the URDF.chakro and that appear on RVs are not the same materials that we put on the gazebo.chakro file. Typically, the gazebo materials are used like this. So you have to put gazebo / the name. And here you just put the name of the material. They are not the same because I think in theory they should be the same so that this is completely unified. But the question is, if they were the same, then you would only define in one place. And many robots do not have simulations. So in that case, I think this was not done in the best way, but I kind of understand why it's done like this. Because suppose that first they started doing robots without simulation. And for those robots, they needed some color. So they just put a material for putting colors on RVs. Then they went to gazebo, and gazebo already had colors. So now they have this strange kind of collision, okay?
Yeah, yeah.
They should
Okay.
be the same, but they are not.
Okay, thank you.
No problem. So that's why here we have a pink robot, which actually in RVs is represented in blue. What else? I'm not, I don't know. What's the purpose of the separation of the chakras or the separation of the materials? That was what your question, not one else's question. Okay, okay. So the purpose of separating the chakras in this case was because of this. Sorry? No, there is something else which I was forgetting. Before, let's just put Sarah's color in low caps because that's our convention for RVs materials. Just to make sure. Okay. Now, Jose's question is interesting because yes, the only thing that changed for now is that we created a new chakra called properties where we added a new material. That's it. Nothing more. There is one more thing, which is the reason, now I remember, the reason why, the reason of being for this exercise 8, which is to tell you about macros. So macros are sort of the functions of chakra files. So to create a macro, so the idea here is that we create a macro for the player gazebo file. Instead of having PM Oliveira gazebo.chakra, we are going to have a macro. If you take a look at this at this file, you can see that the variables that were defined in the initial file pmoliveira_rdf.chacro are actually usable in the other file. So we can use variables that are defined in one file in the other. This can be useful. By the way, these variables are called properties. So here I can define the property. Where is the property here? I'm not sure if in this case I have a property. I don't. But when I have some variable, I can use it in the other place. It's the case of the properties, yeah. So this material blah, blah, blah is defined in a way that then the other file knows about. But this sometimes might not be very useful. And sometimes it is useful to have a single file that can be used with different parameters. One example is the, so we were working on something called larcc. I'm not sure you know. I think I've shown it already. Let's see if I can show it. larcc. Just a moment, I will find the larcc. Yeah. So this is larcc. And what we had to do was an rdf.chacro of this. The question is that this may have one table or many tables. So what I did was a macro, that's like a function, a chacro function, where we define the height as input arguments. We define the height of the table, the width of the table. So I have several properties that I give as input to the macro that end up defining the type of table that I have. Okay, it's like doing a function in chacro. In this case, the application will be this is the properties. Let's see. Yeah, so this is the gazebo macro. Okay, so this is the macro that we need to have. And how do I define this macro? Let's see.
Will this macro define the color of RVs and gazebo at the same time?
No, this macro, in this case, we are going to take away this PM Oliveira gazebo chacro and create a macro. So we have to take a look at the variable that it uses inside. It uses many variables. One of them, for example, is when it simulates the LiDAR. For example, here, it is simulating the LiDAR here. We can use the argument laser visual. You see here, argument laser visual. So this, if I don't know what this is worth, if it's true or false right now. But if I put here true, we can see a visual output of the simulation, for example. Okay, so these are the laser beams, the laser scans that are being projected from the LiDAR sensor of the robot all the way in front up to a maximum value of 5 meters or something. And when they hit something, that's when you produce the data that you see in the laser scan, okay? So that's just the example of a variable that you may want to turn on or off inside your macro. And how to do this is as follows. Let's see. Let's see the header first. So you can see here that we have, I don't remember the syntax. I have to check in my tabulas. Yeah. Okay, thanks. It's actually more or less similar, but this is here. Yeah. So this is what I did. And I will show you the difference. Actually, first I will copy this there. And then we compare. So I'm going to replace the one on the left by the one on the right. Look, the one on the left is just a common chakra file. The one on the right is a macro. It's like a function. So if it's a function, we have to define the input parameters of that function. That's what we are doing here. We are saying parameters, player color, laser visual, that's the variable I've just shown, camera visual, blah, 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 blah. Okay? So these are the several parameters that we are going to use as input parameters for the function. And then how do we use these parameters? For example, for the player color, we use it like this. So whenever we want to use these parameters of a macro, we do it like this. So we just say dollar, brackets, I'm not sure how this is called, I think it's brackets, and then player color, the name of the input parameter, okay? So for example, for the laser visual, we are going to use it like this. Now, if we want to use the chakra, now we don't include in the other file, so in the file that is supposed to call these two, or one of them, the PM Oliveira, before we did it like this. Like this, but now we don't do it like this. So now we comment this, and we have to call it as if it is a macro. And you asked me how to do that. I'm not actually sure. Again, I'm going to see how I did it because I don't remember. Like this. I'm going to copy and then we discuss. So look, I'm saying gazebo macro. Actually, I think I need to include it still. Otherwise, it will not know. Yeah, I have to include it, of course. So I include my file which contains the macro, and then I say, this is like calling a function. So gazebo macro, why is it called gazebo macro? Because that's the name of the macro. You see there, chakra macro name gazebo macro. So this is the name of my macro, the name of my function. Then first argument, player color, it is going to be player color. Laser visual, I don't want to see it, false. Camera visual, I don't want to see it, false, and so on and so forth. Mm-hmm. It seems like I'm overcomplicating, right? Okay, so now an example. Suppose that you have a macro, or before the macro, a chakra for a table. And now I want 100 tables. What do? You create 100 files with different values there?
Okay, I don't know which on the terminal,
It could be, but the macros are helpful when you want to replicate by parameterizing. In this case, I know it's like I'm over-engineering the problem, but this was just to show you that macros exist, basically. I know. Makes exactly. In this case, of course, it doesn't, because we have a single instance, so it's not really important. I tell you where I've used it. I use it on large CC, so I can even show you this. So new window, large CC. Where is it? Robots. Large CC. Description. WordDF. So a lot of stuff, and here we have a table. So I remember I was doing this table. So I decided to do it as a macro. So I have the name of the table, the parent frame ID. This asterisk means it's a lot of stuff, not just one. The height of the table, the radius of the legs, blah, 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 blah. And this is interesting if I want to do more than one table, for example.
And if you want to do that, how do you create more with different parameters?
I would have to call several times, like here, for example. I do this 100 times. Exactly, but it's better than writing this 100 times. Okay. The most complicated chakras and macros are that I've seen so far are with a robot that we have up there, which is URD, Universal Robot, which is really, really complicated. I was a month working with Danielle on that because it was so complicated. I can show you. It was also for the RCC. And where is it? Not here. No, also not here. Here. Because, for example, the RCC is very complex because the chakra itself has input parameters. So this is the chakra property, but then we have also arguments, and these arguments need to be given to the chakra. So you see here a chakra which contains arguments inside. So this was really very, very, I think, overcomplicated. But if you want to take a look, I think you can take a look also. But in this case, I don't think we will need it, okay? I'm just overshooting here. Then we get to the exercise 9, which I've already shown you, okay? So I don't have any more stuff to tell you. I want to see, Sarah, I want to see you driving. Did you put your name on the wiki already? Okay, okay. Ah. George, yeah. Okay, let's see. So you need to change what? Ah, so you cannot show it. Yeah. Okay, okay, okay. Yeah, to connect to Zoom. Okay. So the good thing about this manual driving that you don't know how to do is that next class we are not going to do manual driving. We are going to do a program which drives the robot. Okay, so we are going to do an automatic driving program. This is just yet another program that is also running, and that is going to publish CM command velocity, command messages, doing like the teleop, but instead of the decision being from the user, it's from the program itself. Sorry?
I will unmute, but I don't have phones. Okay. I'm speaking. Então, then, what I did to use the mobile, the cell phone, is I went to the Wi-Fi and I saw my IP address.
Okay.
And I need to see the port of the robot. That's this one.
Yeah.
Unfortunately, I can't show the app, but I use the value of the network, the Wi-Fi with the port, and we can show the different arguments.
Is that on Zoom also?
No, because I can't show it.
You can go. I don't have Zoom in your telephone.
No, it's new, so I don't.
Okay, okay. But what app is that? You just found RAW?
In the Google App Store, it has.
You just browse there, we can see. In the Google App Store, An application for ROS? Okay.
ROS control.
Okay, nice.
To drive the robot by with the phone.
I heard the story about the Tesla car, where there was someone, I think the guy had Tesla parked in the garage, and the gardener needed to pass with that car that cuts the grass, but it couldn't. So he said, "Oh, can I pick up the car, the key, and put the car back so I can pass with the blah blah blah?" And the guy from his office said, "No, don't worry, I drive the car from my phone." And he drove the car from his phone to park back.
It has the maps and the
Nice.
and he even has the camera. My camera isn't working. I still didn't get why. But I think it's because of the RTP graph. It goes to a image raw. I think that only works with the physical robots.
Okay. But
it's this. We can change the topics for the name that we want.
so just configuring your application there.
In the
So that you
application.
can speak to the computer.
Yes.
Okay.
The thing about this is that I can change the velocity.
You can change what?
The velocity of the robot. I still didn't find that.
Yeah. Now you have to do a new application for
Yes.
Android, which is not so easy.
But it's really easy. It's more easy than with the remote.
Let's see, show us. If you want to pass the course, don't do better than me in this attempt.
I will not do it. He's moving using the remote.
You are driving like what? Pressing or just driving like?
I'm just pushing. Just like a joystick.
Okay. I thought it was using the accelerometers of the.
No, I can use tilt with the remote. I can tilt the remote.
Nice.
Yes.
Okay, now you're going to. But it works very well. I thought it was going to be with more lag. Well,
But now I'm tilting, so it's really hard.
more or less.
It also has waypoints that I think it's need to use the camera. I can choose where he wants to go and he goes there. And it's that.
Very nice.
He also has random walk, but I don't know what that is.
Random.
Random walk. Yes.
That's a good question.
These are the topics that I put in the Android. So
That Android robot controller is the node that is running on your phone.
yes,
Well, actually, the camera view also, because it's all inside the Android.
yes.
We do in a terminal raw node info Android robot controller.
ROS node info.
Info
What?
Android robot controller. I think it's /Android. It's too small, I cannot see. So, I was just trying to see if you said that it was on another device. Could be. What is your the IP address of your do a config that? Config. This tells you the IP address. So your IP address for the computer is 192.168.227.
Yes.
And that's very
Yes.
Okay, nice. Actually, ROS does something very simple, very similar to TCP/IP. It's called TCP/ROS. You can see that transport is called TCP/ROS. But it's TCP/IP, yes, more or less. Give or take a few things. That's why it works off the shelf when you go from two nodes communicating in the same computer. to know the communication with the devices connected by Wi-Fi. That's why it works so well. This is, it seems like it's nothing, but it is like a miracle. From people who used this in the 2000s, it was very difficult to do this. I mean, it's not 10 minutes like
Yes, this was.
French take more, but not 2 weeks. It's completely. Okay.
It didn't work. I can put my joystick working. It works when I use the normally when I see the topic, but in the car it doesn't work. I don't know why.
Sometimes joysticks need to be scaled. They need to calibrate it because, for example, in a joystick, when you do this,
Yes.
how does it know if you're supposed to send 0.2 meters or 0.0002 meters? It doesn't know. So you need to do a calibration or mapping between the range of the stick and the range of the velocity you want to change. Send.
If you use the digital little arrows, not the analog.
But it's the same in the physical errors. If you go the maximum of the error, how much velocity is this? If the maximum input from the user is 0.0001, it doesn't move to it. I remember when I used joystick with division cellular. So it takes 25 minutes. So I tell you, keep on trying, and then you're going to try to find a joystick up there. I'm not sure I have one, but I will try to find.
Okay.
Venho já. So I couldn't find the joystick, but while I was going, I had a nice idea, a challenge for you to try during the weekend or something when you have time. If you would like to try something, one thing, you know, the cars that we have now have many what they call ADAS, Advanced Driver Assistance Systems. One of those systems is a system that looks at a range measurement and sees if the car is going to collide. And either operates only when it knows the car is going to collide and brakes automatically, or doesn't even allow the driver to collide. So you could try to do a system that is monitoring the 3D LiDAR, the LiDAR, not the 3D LiDAR, the LiDAR, and knows if the car is going to hit something. And if it is going to hit, the system could force the robot not to hit. So you could try to create a system where the user, you can give it to a baby, the baby starts driving the car, but never hits anything, okay? Well, good luck with that, because that, I think it will take a little bit of time. Something else. Manel, are you there?
Yes.
Okay, one question. I was up there and o engenheiro Rui,
Sim.
vocês pediram-lhe uns monitores e ele diz que
Sim.
é capaz de ter alguns no armazém para você passar lá a falar com ele, que ele depois vai conseguir o armazém procurar a ver se algum lhe interessa.
Tá bem, tá
Acho que é
bem.
para os semáforos do Automec, não é?
É, exatamente.
Pronto. Quando puder, falo com ele. Sabe quem é o engenheiro Rui Heitor, não sabe?
Sei, sei, sei.
Ok, ok.
Ok, obrigado.
Nada. Okay, so if no one else has anything to ask, okay, go ahead.
Something not related to this exercise. How can you implement ROS in hardware?
In hardware?
Yes.
What kind of
Like,
hardware?
how can I put my code, Python code, probably in hardware, because it's not made of C or C++.
In Arduino?
Hardware, any kind of microcontroller.
Okay, this is hardware also, a laptop.
Yes.
But you mean embedded systems? Okay. So this is a question. First, for example, when I went to, where is it? In Mangualde, PSA, the factory that does the cars in Mangualde, there they had one solution for everything, which was Raspberry Pi with Python. Yeah, it runs with Python. So I actually, I hate embedded systems. So I always try to say, don't use embedded systems. Because it, yes, how to use it? What do you mean? I buy, well, for example, I had to do something which was on a tripod, controlling a LiDAR. So it was the perfect application for an embedded system. But I didn't buy any kind of Arduino. I bought Intel NUC. You know Intel NUCs? I show you. These are like computers this size, 300 euros or something. Intel NUC. Well, yeah, something like this. This is a real computer. This is not an embedded system because actually mine is like this. The time you take, especially if you want to use ROS and install Ubuntu and blah, blah, blah. If you buy an embedded system, like even a Raspberry Pi, just to install ROS there is so difficult. You take so much time. The amount of messages I see in these forums, oh, I wanted to install ROS in the Raspberry Pi, but that's an ARM architecture. It's not a blah, blah, blah architecture. Okay, for a small drone. Okay, so the second part of the answer is you can try to use Arduino, I think, because Arduinos are quite cheap and very, very nice. I've never programmed, I think I programmed only one Arduino. The time where Arduino ROS. I was actually, I think Arduino has something that you can use, which is raw serial. So you can communicate with the Arduino. So you do the code in Arduino with, I think it's BASIC, something like BASIC, no? Inside Arduino. Okay, okay. And then you communicate through serial line with the ROS nodes. So you can have your Arduino working on inside the ROS ecosystem. I've never done it, but I know it can be done. No, well, depends what you want. This is, for example, for an application.
Let's say, for instance, that I want to build a drone. Actually, I already have one, and I want to change it and try to do something.
Okay.
So how can I do it without connecting to the computer?
What do you want to what kind of processing do you want to do on board? Do you want to process images, for example? This is very difficult to do with an Arduino, almost impossible, because Arduino don't have the amount of computing power.
Yes, probably an STM.
Okay, so you can try to upgrade your embedded system, but now you have a little bit more power, but you still have the problem of not being able to use OpenCV, Ubuntu. So you have, well, perhaps you are able to, but you need to.
What you're saying is that all the software I have to embed on the hardware.
And it's difficult. It's not straightforward. But yes, but you will need to install some OpenCV or something to do image processing. And if you want to, actually, it's especially in a drone, it's never just let's call it just operating system. It doesn't matter if it is a NUC or an Arduino, but you will have an operating system, a computer working on the drone, and you will need something on the base station, no? But because you need to do teleoperation or not? Maybe, yeah.
That's why I'm asking for a solution, not directly connected.
Yes. Oh, physically connecting. You can use Ethernet, Wi-Fi for that.
Wi-Fi?
I think Wi-Fi. I think.
So pretty much what the phone did, right?
Yes, that would be my first try, yeah. Something like that. Just connect them using Wi-Fi. And that's it. For example, I bought a drone for my kid this Christmas. And the drone comes with a controller which connects through Bluetooth. So through Bluetooth, I can control the drone in terms of going forward and backwards and blah, blah, blah. But the drone also creates a Wi-Fi network to which my phone, my Android, can connect. And when I'm connected through Wi-Fi with the drone, I can also see the images of the drone and this kind of stuff. So I would say something like this. For me, the most difficult part is always working on embedded systems because it's always more complicated than doing in real computers. That's why I don't like them. Because, for example, I want to do image processing. Oh, you don't have power. Okay, now I have power. Oh, you don't have the libraries. Oh, I'm going to try to install the libraries. Oh, they don't work. Yeah. But are you sure that a better system like a Raspberry Pi or something doesn't? Yeah, perhaps. I don't have experience with embedded system because I hate them to death. Well, actually, when I did when I was finishing my course, I stayed for a couple of weeks working on embedded systems because we had to. So our robot was a computer like this, which then connected to two microcontrollers. Arduinos did not exist at that time. And they connected through serial port. And then they would say, for example, to the microcontroller, I want to move my traction wheels at speed, blah, blah, blah. And it would start turning the motors. But that was so complicated, so many bugs, so many that I created a special hate for embedded systems and I don't want to. So now I don't know, I never work with that. When I want to do something embedded, I buy a NUC or something. If you want, I can borrow you my Intel NUC and you can try it. It is, yeah, it is very nice. It is not an i7, I think it was an i5, but still it's like a computer. I'm not sure if the drone, the weight the drone can carry. Intel NUC, i5 weight. Do you know what kind of weight you can carry?
No, but just looking at this dimension, I'm not sure if you can carry that.
Yeah, perhaps. Yeah, perhaps not. Peso? Oh, não tem peso. Filha da mãe. Tem peso e dimensões, depois não tem nada. Product specifications. Weight. Também não. Dimensions. Olha, não tem peso. Não sei qual será o peso. Mas depois... eu não sei. Olha, não faço ideia. E depois tem um problema. É que este NUC não tem bateria. Porque se tem que ir no drone, como é que vai alimentar? Não, por acaso o NUC por acaso tinha uma coisa fixe, que é, dá para pôr, tinha duas formas de alimentar. Ou se alimentava com corrente DC, que pode ir de umas baterias, não sei se era 24 volts, não sei quanto, acho que era 19, ou então diretamente de uma coisa destas, ligada ao power supply. Mas, são tantos problemas para resolver. Eu acho que você devia falar com o professor Zé Paulo Santos, com o professor Vitor Santos, porque eles gostam mais de Embedded Systems. Eu fujo deles como o diabo da cruz. Diga, Sandro. Desculpe, Lucas. Quase meio quilo. É muito, não é? Pois. Yeah. Can you share your screen and show us? But this is not a drone. This is not, okay. No, yeah, it's possible for sure to do it. Oh, look, it has a Raspberry Pi, it's there. It has a Raspberry Pi. Yeah, and for example, Raspberry Pi here, you can see there, Raspberry Pi 3B Ubuntu. Ubuntu is a special kind of Ubuntu for lightweight systems. So then you want to do gedit, doesn't work because Ubuntu doesn't have it. And and ARM is a special architecture also. You have to recompile stuff for ARM. Okay, but it's a big challenge. If you like challenges, it's going to be a big challenge. Sorry for not helping more. But embedded system. You should speak to Professor Vitor Santos. I think he's going to. You are on the 5th year, no? Because I think there is going to be a course in the it's called Projeto Sistemas de Automação. I think he's going to propose people to do a drone. Yeah, so perhaps you should speak to him. Well, okay. People at home, do you need something else or not?
I don't think so.
Okay. So see you next week.
See you.
Bye-bye.